In the universal set, which contains the digits from 0 to 9, A is this set, B is this set, C is this set. So what we're looking to do here is fill in the Venn diagram. Now 3, 4, 5, 6, 7, 8, there's an overlap with the 4 here and with the 4 here. So the 4 is in all 3 sets. So that's going to go right in the middle. So let's just take that out of all the sets. And there's nothing else that's in all 3. So let's compare A and B. So there's no other elements in both of those. So the A and B section, which is here, is going to be empty. Let's look at A and C. So we've got a 3, which must go in here. And then there's nothing else. So let's look at B and C. Well, we can see that the 2 is in those. So B and C. So we've got the element 2 goes in here. Note it's not in the middle because it's not in A as well. It's just in B and C. So there appears to be no more overlap at all. And so A is going to have the 5, the 6 and the 8 in this part. The B will have the 9 in this part. And the C will have the 1 in this part. So we've got 1, 2, 3, 4, 5, 6, 8 and 9. 0 and 7 are missing. So they must go out here. So they're not in any of A, B and C, but they are in the universal set. Now we want A union B. So A union B means it's in A or B or both. So that's all of these elements just here. So that's going to be the set containing 2, 3, 4, 5, 6, 8 and 9. So that's A union B. A intersection B is just those that are in both. So that's that bit here. So in there we just simply have the 4. So it's this part here that's in both A and B. Now we have not A. So that means everything outside of A. So if this is A, then we're after everything that's outside of that. So not the shaded bit, but the unshaded bit. So we've got 0, we've got 1, we've got 2, so 0, 1, 2, and also we have 7 and 9. So let's just get rid of that shading. So what we now want is not C intersection A. So if we identify C intersection A as this part just here, it's going to be everything that isn't in that bit. That's what the bar means. So we've got 0, 1, 2, 3 and 4 are in here. So it will be everything else. So 0, 1, 2, 3, 4, we skip. 5, 6, 7, 8, 9. Let's take that out. Then we want not C in union with not A. Now there is a trick to this. So let's shade to start with not C. So what we need to do is have a ring around C, and then we'll shade everything else. And so we've shaded not C. Then change the colour of our shading. So let's make it a blue or something. And then we're going to shade not A. So what we need to do is go around A, and then we'll shade around everything that isn't A. Now this is a union, so we take everything that's shaded, whether it's shaded once or twice. If this had been an intersection instead, we'd have just taken the double shaded bits. But for a union, it's whether it's shaded once or twice. And I can see that's everything except the 3 and 4 here. So 0, 1, 2, 5, 6, 7, 8, 9. Now comparing these last two, we can see that C intersection A naught must be equal to C bar in union with A bar.